Morning, guys. This is our video for day 4. This video is pre-recorded, so I won't be able to answer questions live in the video. But if you have any questions, you comment on the post and I'll message you guys back between the times of 8:30 a.m. to 11 a.m. every day. For some of you, this video will be posted earlier than your scheduled class times because it's just one video, but it's the same video for all the third form classes that I teach. So remember last week I posted a message saying that I'm going to start posting one video and you guys can work on it anytime, not having to be online during class times to watch the video, and submitting the assignment before the Easter break, right? Submit all assignments. That's gonna be 6 of them in total, right? 5 if you don't include the first one, which was just to enter your name on the class. So 5 if you really think about it. So again, if you have questions, post it in the comments of this video that's gonna be posted. Our videos will still be accompanied by the form to allow you to post the assignment. So let's begin this. Today we're gonna start with a topic called trace tables. It builds upon algorithms and over the code and the flowcharts we've been doing so far. If you look on the left side, you'll see that trace tables are instructions in an algorithm with given data to produce solutions. Basically, a trace table is a trace that happens. You're following what's happening in the code, but you're more looking towards the solutions rather than how the code is structured. So pseudocode is basically how the code would be structured, more or less, using a middle ground language between English and code. So that's what pseudocode is. What we've been doing in QBasic is actual code, and the flowcharts is a visual representation of what we've been doing. Trace tables now are like the solutions or the different values you would get when you input certain values. This table displays all relevant variables that may change throughout the algorithm when the program is running. And the important thing to note here is the word variables. Alright? These are what we keep track of in a trace table, and basically we can predict solutions based on the trace table of our program. So let's begin with a simple program. Alright, this program adds 2 numbers. We simply ask the user to enter the first number. We'll store that number as num1. We ask that user to enter the second number. We'll call that num2. And in this case, we're not going to simply just print and combine the num1 plus num2 with a semicolon. We're going to just actually assign answer equals to num1 plus num2. And now we'll print out the word answer. We'll say the sum is, and then we use a semicolon to just put the word answer because that's our variable. Note that num1 will be added to num2, but that's until the user enters those numbers, right? We don't know what those numbers are, but we know for a fact that answer, which is another variable that we created, we call it answer, is going to become, or is going to store the value that is calculated when you add num1 plus num2. So number 7, line 7, is saying the sum is, and instead of putting the calculation of num1 plus num2 there, which we've been doing this already, right? But instead of doing that, we're just going to put answer because answer already contains the answer for us. So we don't have to perform the addition on line 7. So how does our trace table work? Well, we'll go ahead, go into Word, going to create a table. We're going to create a table with It's 3 by 5, 3 columns, 5 rows. And basically what you're gonna do in your trace table is to name the variables. What 3 variables are found in this program? We start with the first one, num1, num2, and then answer. So those are the variables, right? Those are our containers. These hold some values so far, right? It's just that we don't know what it is until the person runs the program. So for example, all we're doing here is just producing results for answer. If I give you guys 5 and 3, and then I ask you guys for 4 and 14, 20 and 56, and then 100 and 256. Now, what would the answer be related to this program here? Well, this program adds these numbers, and we can both find the answer manually, which we just go ahead and add answers from num1 and num2, or we can run it in the program and see what the answer is, right? But that's basically what a trace table is. We use the table, we put in the variables, we put in possible values that can be stored in the variable, and we can fill out the answer column in this table, right? Other tables will look differently depending on different conditions, but this is just a very basic representation of a trace table. And I'll be giving you guys assignments and even quizzes or tests, not during these 2 weeks, right? But when we get back to school, I'll be giving you tables like these, and you should be able to come up with the answer, right? If you look at just this Word file, obviously it doesn't give you any context of what this trace table is trying to represent, right? If I just give you a table that says num1, num2, and answer, would you know what the answer would be? No. It's important that you know what program or what the code looks like, right? So that's why we want to accompany trace tables with the programs. And now if you read this program and say, alright, this adds 2 numbers, we know that num1 is the variable for the first number and num2 is the variable for the second number. So answer equals num1 plus num2. Therefore, now we can just go ahead and add our answers. And what I'm going to do is going to change the color. So 3 plus 5 is 8. We know that to be true. 14 plus 4 would be 18. I'm gonna go ahead and turn that red. These will be the parts I enter, right? And one way to confirm is to test your code and make sure that the answer is correct. So that's really all it is. Tracing or following up with your variables to see what happens in your algorithm. This is very easy for this table because again it's just a very simple problem. Add the first 2 numbers. Now if we had an if-else structure here, now it's gonna get more complicated, but let me go ahead and finish adding these numbers for you. So this one would be 76 and this one would be 356. So it's basically a good way to check if the expected answers are what you wanted it to be, right? Remember, one of the things with an algorithm is that it's correct, but correct doesn't always mean logically correct, but correct in it's the answers you expected it to be. Alright, so this is a basic program that shows a trace table. If I were to ask you guys to create a trace table following the program we did last week, let's see if I can find it. This would be the flow chart, and in this flow chart we have one input, so that's one variable that we call operation. We have 2 and 3, which is value 1 and value 2. So based on these variables, our trace table would look different, right? Because we'd have a table that now not only includes value 1 or value 2, it would also include operation, and based on the operation it drastically changes what these answers would look like. For example, in the calculator program, we had value 1, value 2, but we would have also had to put, and I'm manipulating this now to more look like our calculator program, and instead of num1 and num2, we had value 1 and value 2, and we didn't have an answer in our code for that day, right? For the calculator. The code for the calculator, I'm gonna copy it from here, had the statement just printed out, which I've shown you guys already, right? But we could have easily just put the word answer, and then from here, actually I'll put it inside here. We could have just said, alright, answer equals, and then we just copy this, paste it there, and just put answer instead, just like the previous program. And then we would easily be able to just say, alright, well, now we have an answer variable here, and we could produce answers based on operation, right? So this is where it gets a little bit different compared to the first one. The first one was straightforward. We had 1 plus 1, 2, 5 plus 3, 8, 100 plus 256 is 356. It's straightforward. But the reason why trace tables are useful is when you have conditions. What if operations was 25? Then we wouldn't reach answer. Remember, if operation is greater than 2, then what we would put here is basically invalid, right? Because it wouldn't go much further from there at that point. What if operation was 2? It's no longer an addition that happens when operation is equals to 2. When operation is 2, then we have a subtraction. Then what happens here now is we would say answer equals, and then we'll cut this from here and basically just substitute that for answer, for the sole purpose of saying that, alright, we have a variable now that's called answer, and based on what operation is, answer will take on the respective values, right? So if operation is 2, then we're performing a subtraction, right? So answer now equals to value 1 minus value 2. So this time it's not 4 plus 14, but actually 4 minus 14, and now the answer is completely different, and it should be negative 10 at this point. So a trace table can help you guys figure out the logic of your code. If you can put the code's variables into a trace table and then the values are correct, then that shows that you actually understand how the code is running or what the code is doing, right? So again, if I put 1 here, now that's a valid operation, and it's the one for addition. So we can say if operation is 1, then when these values are entered by the user, then we get 76 still, because in this case we are adding the 2 values. And then in this last one here, if I put negative 3, then of course that's another invalid option found here. So if we were to write a trace table for the program we did last week with the addition of variable answer, then we would say this is how it looks using these default values here, right? So that's all I wanted to talk about today. Your homework now, your assignment, is basically to create a table of the following. So I'm going to put assignment here. Want you to create another table. Let's do 5. It's a really simple assignment. I'm going to put operation again, and this is based on the calculator program that we've been doing from last week. Alright, these variables, if you notice, because I'm typing it out in Word, the first letter is capitalized. Just make sure you understand that it's not really that I'm trying to make it capital. it's just default by word. I can go ahead and fix it, but we all know what's happening, right? If you have it as caps, it's no problem. You understand what's happening. So this part is your assignment. I'll put a bunch of values here, and all I want you to do is finish the assignment. It's a very short one. Just gonna put 5 values, and what I want you to do is fill out these 3 columns here. Put any numbers you want, fill it out, and make sure the answer is relevant to the operation value here. So these values are the default values I give you. Value 1 and 2 would be representative of the values that the user would enter, and we don't know what it is yet, so I want you to go ahead and put in values of your own, and then I want you to put the correct answer based on these values that I've placed in the operations already. So if operation is 2, what would happen to value 1 and 2? Give me the answer. If operation is 1, what happens to value 1 and 2 as the answer? And then if the operation is 25, what happens to value 2? Well, in this case, you don't really have to put values like I did here. In the code wouldn't allow you to even put any values, right? Because of this check. Therefore, the answer would actually just be invalid, because it wouldn't even reach down here. It would just end on lines 11 or 14, depending on what value you put. That's greater or less than 2 or 1 in the operation check found on line 9. So go ahead, I'll give you this one. Go ahead, put in values for 1 and 2, for 0 and 2 as well. So fill in this table for your assignment, and as usual, send me the document on the form for day 4. Alright, so I'm gonna go ahead and save this, following the same naming convention as usual. Alright, so I'm gonna put 34. Okay, that's it for today. I'm gonna end the stream now. If you have any questions, go ahead, send me a comment on the chat. Not on the chat, sorry, on this Google Class stream, or send me a private comment in the assignment section. Alright, guys.